and I'm sharing my screen. Please indicate if you can see the screen. Your mics are on, so please just share with me if you can. Yes, no? Yes, no? Hello?
Yes, ma'am, I can see.
Thank you. We're going back to the particle size distribution. What is particle size distribution or sieve analysis is a test that we do on soils to grade the soil. Why are we grading the soil? Because we want to find out what type of soil are we dealing with and understand its properties so that we make informed decision on, are we going to build with it or not? Are we going to use it for our road layers or not? Is it according to the specifications that we need or not? We already did a lot of things, and we have an understanding that you will have different sieve sizes, right? So these will be the sieve sizes. And this side, you'll have after you've done everything, you'll have the percentage passing. You'll have percentages here. You use those percentages to draw a graph, right? This side, so it's like this, it's like a box shape. This side you'll have your percentages. This side is also percentages. And here, this is your normal scale. And then this side, these are the sieve sizes or particle sizes. And this is a log scale. Don't forget, please, I beg. So you have different types of sieves, right? For example, if we say this is a shape that you got, right? So this will be your shape. What is that shape? This is your grading curve. This we call your grading curve. How did you achieve this? You took the sieve sizes and your percentage passing that you calculated from mass retained and percentage retained. And finally, you get your a graph like this. You draw this graph using a flexible ruler because it will not be straight lines, it will be a curve. Remember that. Now, what we need then is to have the grading characteristics. What are grading characteristics? Firstly, before we move to the grading characteristics, we have coefficients that we need to calculate, CU and CC, right? What's the formula for CU? Is D60 over D10. What is a formula for CC? Is D30 squared over D10 times D60. So these are the grading characteristics. We use these to grade the soil. In essence, in summary, what do you really use to grade your soil? You look at the shape of your curve and you look at the value of CU and CC. These three things, they will inform you about the grading of your soil. These three things, the shape. When you go to your books on page 27, they have different shapes: A, B, C, D, and E, different shapes. And there at the bottom, they tell you A is poorly graded, B is well graded, C is gap graded, D, depending on the shape. What do you need to understand? What do they mean? How did they know that is well graded or poorly graded or whatever? For example, if I say this is well graded, okay, how did I realize? We said a well graded soil is soil that will have all the particles, if not most, they will be represented in that that curve or that soil. If this is the biggest particle, right? And maybe this is the smallest particle. From here, it's big to small. Then what does that mean? It means that you do have 50, 35, 20, 11, 0.425, and the smallest particles you also have. So what does that mean? It means that you have almost all particles represented. If you had a shape like this, right, in terms of what is represented is only from here to there. So it means that there are limitations because you are only here in terms of sizes. Then it means that that soil that you're talking about is poorly graded because some particles from here to here, the bigger ones are not there. Even from here to there, the smaller ones, they are not there. Then what does that mean? That's how they will say that soil is poorly graded or that soil is gap graded or whatever. So when you look at those shapes, look at the shape and understand. Because when they give you that shape, it will have, they will represent the soil in terms of sizes, right? And say cobble, gravel, sand, silt, and clay. The well-graded soil will move from the cobble side and or gravel all the way to the silt. Sometimes it overlaps into the clay, depending, right? When you look at the C, which they say is gap graded, it's only cobble, gravel, and sand. But when you look at the shape, it's not smooth. It has it's like this. So that represents something because it means that other particles, there is a bigger concentration of them than others. It's not smooth, right? When you look at the A, which is polygraded, we already explained. The E, which is a typically silty clay, it's only somewhere here. So it's like that. It means that only silt and maybe clay, but other soils in terms of sizes. So don't focus, because when you're looking at it, the graph that you will be given, sometimes it won't say cobble, gravel, sand, clay. No. So look at it in terms of the percentages and also the sieve sizes. The sieve sizes, when you look at it, is the graph spread throughout all of them, different sizes, or it's only limited to a certain portion. So that's how you look at it, number one. Don't forget about that. So that's why I said it's important to remember what is important, the shape. The shape is very important because the shape is important because it will inform whether the soil is well graded or not, but not only the shape, the value of Cu and Cc as well. How do you determine the value of Cu and the value of Cc? This is how you determine them. You have a shape, you have a graph, and you have a shape like this. You have percentages, you have sieve sizes. So they talk about, in the formulas for CU and CC, realize up there, they talk about D10, D30, and D60. What are those? When we're talking about D10, D30, and D60, we're speaking about this. So this will be 0 in terms of percentage, and this will be 100. 0, 10, 20, 30, 30, 40, 50, 60. Okay, let's say this is 10, this is 30, and maybe this is 60. When you're determining the value of D10, D30, and D60, what do you do? At 10%, this will be at 10%, at 30%, at 60%. You will draw a line, a horizontal line. Where that line intersects with your graph, you draw a vertical line. In terms of sieve sizes, the size that you get here will be your value of D10. D30, you do the same. Horizontal line, it intersects with your graph. This is your value for D30. So the value that you get here, if it's 2 millimeters, then the 2 is, if this is 0.425, then that is the value that you're going to use. Also with D60, same. If let's say the value that you get there was 9.5 or 6 point whatever, you note that value down, and that is your value for D10, D30, D60. Why then did I say it's important for you to understand or read off from a log graph? Because this side, it's a log graph. So if you don't know the scaling when it comes to a log graph, you will not be able to pick out these values. Remember, from when we started. So it's very important that you know. Don't forget, it's very important, because in terms of values, you need to know that this is 10, maybe, or we're moving from a 0.1 to 100. How do they how do you then do a log graph or a log scale? You need to know how to do it. So the value of D10, D30, D60, that's how you get them. And then you will calculate with them, because you have a formula, the value of D60 and D30. So if maybe we were determining the value of CU and we found out that this was 6.4 over D10, maybe was, we said 0.425, then it will be over 0.425. You punch that in your calculator and you get the answer. That is your value for CU, sorry. CU. You do the same for the CC. What do you do with the values that you get? They tell a story. If the value of, like, so they tell you that once the coefficient of uniformity and the coefficient of curvature, coefficient of uniformity CU, coefficient of curvature CC, have been calculated, they must be compared to published gradation criteria. Both CU and CC will be one for single-sized soil. Okay, we're not looking at that. If the value of CU is greater than 5, those conditions are also in the book. If the value of CU is greater than 5, you're looking at well-graded soil. If the value of CU is less than 3, this indicates uniform soil. If the value of CC is between 0.5 and 2, the soil is well graded as well. But if the value of CC is less than 0.1, it indicates a possible gap-graded soil. What did I mean by you don't only look at the value of CC and CU? It means exactly that, because sometimes you might have a combination of something, and therefore you need to go back to looking at your shape. What does the shape say? What does the value of CU mean? Where is the shape of CU? Is it within the the scale, or the what's the range, rather? Let's use the word range. Yes, because it's between something and something. So if it's between that range, or it's less than that particular number, you look at CU, and you will look at CC, and you look at the shape. So either or, you need to make a conclusion based on what you're seeing. That's where your application of the knowledge you would have gathered comes in. If you're looking at a graph, right, your grading curve, and you find out that I'm looking at the value of CU, I'm looking at the value of CC, and then maybe I asked you, comment on the grading of the soil. How do you comment on the grading of the soil? You will tell me the soil is well graded. Why? The question will be why? Why are you saying it's well graded? Maybe you'll say it's well graded because you looked at you'll comment on the shape, you'll comment on the value of CU, you'll comment on the value of CC, right? So you look at those three things. So don't just get a question and says, comment on the grading of the soil, and you just say, the soil is well graded. That is poor way of answering that particular question. Why? Because they make a disclaimer even on your book. They say once the coefficient of uniformity and the coefficient of curvature have been calculated, they must be compared, right? So those ranges that you use, you compare with those, because those are your starting point. So in everything, remember, when you get to the lab, we refer to the SENS method. According to the SENS method, there are acceptable results and results that when you get, they'll tell you, repeat the test again, or the concrete really failed, right? Because you're not getting the desired strength. If you used maybe this ratio in 7 days, or use this type of cement, by 7 days, you should be getting 20 MPAs. If you crush that concrete and you realize that I'm getting less, it means that there's something wrong. You'll wait for the other cubes. Maybe you'll crush them. If also after the 28 days, they don't give you the required, it means that that batch of concrete failed. If you used that concrete to construct a slab, then it will be crushed, because it will not give us the strength. From the design, we were told that this slab must be able to withstand this amount of loading. If it's a section of road that you did, and then we go and do maybe a test in the lab, either CBR or any, and we realize, no, we're not getting, or we do the optimum moisture content test, optimum and maximum dry density, and we realize, no, we're not getting the density. It means that section failed. The whole section failed in terms of stabilizing. You need to do it again. Because you are not getting the required strength in terms of density. So you look at it like that. Even when it comes to soil, you do the same. You don't just say well graded. Why is it well graded? You compare it with what already exists and is acceptable. You go through that route. So remember, when you are commenting on the grading of the soil, you look at three things. If you're grading the soil, or you're asked to comment on the grading, don't just say well graded. Why? Why did you make that decision that it is well graded or it's not well graded or it's whatever graded? Where? How did you come to that conclusion? That's the most important of this part. So it means that this section is not complete if you don't answer it in that way. If a question was 3 marks, and you were asked to comment on the grading of the soil, and you just say, well graded. It might be that you saw your friend on the side writing well graded, and you don't even know why it's well graded. If you don't get half or 0.5 out of 3, you might get 0 because you don't answer that question that way, especially this one. Other questions, they might be different, but this one specifically, I just need to make a disclaimer that you make a decision based on those ranges. You refer back to them. So you need to know that CU greater than 5 indicates what, CU less than 3 indicates what, CC between 0.5 and 2 indicates what, and CC less than 1 indicates what. And then you just look at the shape. Remember I said when you're looking at the shape, I'm not expecting you to memorize them. No, I'm expecting you to look at them and look how different they are from each other in terms of why on the graph they said this is well graded. You see that a well graded, it will cover different sizes. Therefore, even if you don't have that guidance, you know, when I'm looking at the shape, I'm not just looking at the shape. It needs to be smooth, yes, if it's well graded, and it needs to cover all different sizes or almost all of them. Then I would know that it's well graded. So in terms of the grading of the soil, this is a section that we had not covered, and it's important. Very, very important. Don't forget about it. It means that you need to go to your book, 26, page 26, page 27, look at it thoroughly. When you're reading through it or you are analyzing the diagrams, remember what you need to look at so that you don't have a problem when you're writing a test, because you will not have the book to refer to. If we will be writing it online, then questions will be asked in a different way, of course, but at the end of the day, you still need to know how do you grade the soil using the grading characteristics. And what do you look at? The shape, the coefficient of curvature, and the coefficient of uniformity. That's section 1. I'm going to pause here and ask if you have any questions. Any questions? No questions. Okay. The second section that we need to cover. Okay, it's fine, no problem. Thank you very much. I will stop here and stop the recording as well. We still